Hello dear students, welcome to the ACE online platform. I am Malakondaya Gandham, Thermal faculty in our ACE Engineering Academy. Dear friends, I have more than 25 years of experience in teaching field. As we all know, ACE Engineering Academy is conducting the mega mock test for SSC JE. Dear students, believe me, we all mechanical faculty prepared most important questions for the mega mock test. As a thermal faculty, I prepared the important questions for the thermodynamics, power plant engineering, IC engines, refrigeration and air conditioning. Dear friends, remember, for thermodynamics, most important topics are first law of thermodynamics, second law of thermodynamics, entropy, properties of pure substances and air standard cycles. These are the most important units for the thermodynamics. Similarly, for the power plant engineering, most important units are boilers, compressors, condensers, steam turbine power plants and Rankine cycle. Similarly, for IC engines, working mechanism of 2-stroke engines, 4-stroke engines, the performance parameters, performance curves. Similarly, for the refrigeration part, most important unit is air refrigeration cycles like reversed Carnot cycle, Bell-Coleman cycle and vapor compression refrigeration cycle. In addition to that, you try to practice the right concept from the psychrometry. Psychrometry also very important. Dear friends, remember, writing the exam is very important. Once you undertake the exam, you can come to know what is your level and what the exam is demanding. So there is a gap between your level and exam level. You can slowly fill that gap once you undertake the exams. As we all know, the perfection does not fall to your lap just like that. It means you have to earn the perfection like how your parents are earning the amount or property. So having this part, I am concluding this video, right? I hope all of you are going to undertake the exams. All the best and God bless you. Thank you.
Hello students, I welcome you to the mega mock test of SSC JE Mechanical Department, Fluid Mechanics. Let us look at the solutions for the questions. The first question over here is regarding the concept of ideal fluid. The characteristic of an ideal fluid is. Now recall, ideal fluid is anything which is having zero viscosity, zero shear stress, zero surface tension, infinite bulk modulus and zero compressibility. These are properties of ideal fluid. So if we see over here, it satisfies continuity equation. It is valid for every fluid as such. One which flows with least friction, one which obeys Newton's law of viscosity, one which is frictionless and incompressible. Option D is correct. Why frictionless? Because mu is equal to 0. Incompressible because compressibility alpha is equal to 0. Alpha equal to 0 also means bulk modulus is infinite. Remember these properties. Okay, now this is regarding the concept of ideal fluid. Moving further to the next question, the question is saying capillary rise is a phenomena that is attributed to the following property. Which of the following property basically? Now capillary rise, it deals with the concept of surface tension. If you recall, the formula for H is equal to 4 sigma cos of phi upon gamma times D in the case of a tube. Now you see sigma over here implies surface tension. Therefore, the correct property over here that is associated with the capillarity is surface tension. Option D would be the correct answer. Moving further, this is a very important question, appeared in every examination in India. It is regarding the variation of viscosity with respect to temperature. The question is saying as temperature increases. Now remember, as temperature increases, viscosity liquid has to decrease and viscosity gas has to increase. Opposite nature they are having. This you have to remember. So dynamic viscosity of gas increases, correct. Dynamic viscosity of liquid increases, wrong. Dynamic viscosity of liquid does not change, this is also wrong. Dynamic viscosity of gas decreases, this is wrong. The correct answer over here is option A. Option A alone is the correct answer over here. Moving further to the next question. This question is saying the absolute value of pressure difference between the inside and outside of a spherical soap bubble of radius r and surface tension gamma is equal to how much? Now you see, in the case of soap bubble, the value of delta P we say is equal to 8 sigma by d. Okay, now sigma he is saying is gamma over here, and d you replace by 2r. So this has become equal to 8 gamma divided by 2r, which is equal to how much? It is equal to 4 gamma divided by r. So correct answer over here is 4 gamma divided by r, which is option D. I hope it is clear till here to all of you. Moving further to the next question. The question is saying which of the following pressure units represents the least pressure? Again a very common question. अब देखिए, whenever he asks you these kind of questions, convert everything into a standard unit. Let us say SI unit. So I'm converting each one of these options into SI unit. Millibar. Milli is 10 power minus 3. Bar is 10 power 5 Pascal. So this becomes over here 100 Pascal. 1 mm mercury is called as 1 torr. 1 torr is 133 Pascal. 1 Newton per mm square is a very, very heavy quantity, megapascal, which is 10 power 6 Pascal. 1 kg force per centimeter square is 9.81 into 10 power 4 Pascal. These are the values I'm having. Now among these values, if you observe the least value is 100 Pascal, therefore millibar happens to be the least quantity amongst these values. Moving further. The question over here is saying two tanks A and B with same height are filled with water. The volume of A is 10 times the volume of tank B. What can you say regarding the pressure PA and PB at the bottom of the tank A and B respectively? Now you see they are both filled with the same fluid up to the same height. The pressure is equal to gamma times H. Now since same fluid is there and same height is there, the pressure also has to be same. Even though the volumes are different, the pressure will be same. Pressure has nothing to do with volume. Pressure has nothing to do with the cross section of a container. It deals with the depth of the fluid column and the gamma of the fluid column. So therefore PA over here has to be equal to PB. Option C is correct over here. Moving further. Next question. 1 second. Let me make a small correction. Over here theta is present. ठीक है. The question is saying the height of water in a vessel is equal to H. The vessel wall of width B at an angle theta to the vertical. The net force exerted, I'm sorry, there is some portion over here missing, exerted on the wall is equal to how much? The question is asking what is the hydrostatic force over here? Very, very good question. Now hydrostatic force on a flat surface is equal to, force is equal to gamma into area into H bar. Now if you see the value of gamma is rho g into area multiplied to H bar over here is equal to H by 2. Why H by 2? You see the center of this thing, at what depth is it going to lie? It is going to lie exactly at H by 2. Only thing I have to worry about is regarding the area. Area is equal to this inclined length multiplied to the width B coming perpendicular. To identify this inclined length, I will look over here at this particular triangle. In this triangle, this is H, this angle is theta over here. So this inclined length will be equal to how much? Now you see cos theta is equal to H divided by the inclined length. So length is equal to how much? It is equal to H divided by cos theta. So now I can say the value of force is equal to rho g multiplied to area is equal to length into breadth divided by cos theta. Okay, sorry, length is equal to h by cos theta. I'm sorry, h over here, h into breadth divided by cos theta into h by 2. So basically h square will come, 2 will come in denominator, cos theta will come in denominator. Cos theta in denominator is as good as cos theta in denominator is as good as secant theta in numerator. Okay. So this value has to be equal to, it is supposed to be 1 by 2 rho bh square into g multiplied to secant theta. C will be correct answer. Only thing, it is supposed to have 1 by 2 over there. Okay. Option C will be the correct answer. Moving further to the next question, the question is saying 2 liters of petrol having specific gravity 0.805 weigh 15.8 Newton. The density is equal to how much? Now density is equal to specific gravity multiplied to density of water, that is equal to 0.805 multiplied to 1000. If you multiply this to 1000, you will get exactly 805 kg per meter cube. Option C would be correct answer. Next thing, at 100 degrees centigrade at sea level, pure water will have an absolute vapor pressure of how much? Remember this thing, the absolute vapor pressure of water at 100 degrees centigrade is equal to 101.3 kilopascal. That is the 1 atmosphere basically. Next thing, the center of pressure on an inclined plane. In the case of inclined plane, center of pressure P, where will it lie? He is asking. At the centroid, not possible, because inclined plane is there. So it is supposed to lie below the centroid. So the correct answer over here is option C, which is below the centroid. This is a very, very commonly asked questions in SSC JE. The question is saying the relationship between atmospheric pressure PATM, gauge pressure P gauge, and absolute pressure is given by. Remember the result. The value over here is P absolute is equal to P naught, which is basically P atmosphere plus P gauge. P absolute is equal to P atmosphere plus P gauge. Some books may write plus or minus, but you can also accept plus over here. So P absolute is PATM plus P gauge. I can see the only correct answer over here is option B. P absolute is equal to PATM plus P gauge. Moving further. Pressure in terms of meters of oil, specific gravity 0.9, equivalent to 4.5 meter of water. Very simple question. So pressure by oil over here is equal to pressure by water. So it is equal to gamma oil multiplied to height of oil. Height of oil we do not know, is equal to gamma water multiplied to height of water is 4.5. So height of oil over here is equal to gamma water by gamma oil is S water divided by S oil multiplied to 4.5, which is equal to S water by S oil is 1 by 0.9 multiplied to 4.5. This value, if you check, comes out to be exactly equal to 5.0. So the value of H of oil is equal to 5 meter of oil. So answer is option B, 5 over here. Moving further. Metacentric height is given as a distance between which 2 points? Metacentric height, remember, it is equal to GM. Metacentric height is GM. It is a distance between centroid of the body and metacenter. Let us now see the center of gravity of the body and the metacenter. This is correct. Center of gravity and center of buoyancy, wrong. Center of gravity and center of pressure, wrong. Center of buoyancy and metacenter, wrong. The correct answer over here is option A, center of gravity of the body and the metacenter. Next question over here, iceberg floats in sea water with 14% of its volume projecting above the sea surface. If the specific weight of sea water is 10,400 Newton per meter cube, determine the specific weight of iceberg. Now I can use over here by equilibrium, weight of iceberg has to be equal to force of buoyancy. weight of iceberg is equal to gamma of iceberg multiplied to volume of iceberg. Force of buoyancy is equal to gamma of water multiplied to a volume of water is going to be, see, if 14% is projecting above, 86% is below. So 0.86 times volume of ice. I can cancel volume of ice on both sides. So gamma of ice has to be equal to 0.86 times gamma of seawater, which is 10,400 Newton per meter cube. So 0.86 into 10,400 Newton per meter cube, if you calculate, will come out to be 8,944 Newton per meter cube. Answer is option B, 8944. Moving further. The question is saying in a two-dimensional incompressible end, this is supposed to be irrotational. Irrotational flow, stream function psi and velocity potential function phi exist, correct? The velocities in x and y direction are non-zero. Now, I'm sorry it is not clear over here. They are saying the product of dy by dx for phi equal to constant and dy by dx for psi to be equal to constant is equal to how much? If you multiply the slope of equipotential line and streamline, the answer will be always -1 as long as it is not a stagnation point. So answer is option A, that is equal to -1 over here. Moving further, next question. The question is saying, for a flow, the velocity components are given by u is equal to lambda x y square minus x cube y square and v is equal to x square y cube minus 3y cube. What is the value of lambda for the possible flow field which includes steady incompressible flow? If the flow happens to be steady incompressible, then the equation is supposed to be dou u by dou x plus dou v by dou y has to be equal to 0, which implies. अब देखिए dou u by dou x, if you differentiate this with respect to x-axis, you are going to get over here lambda y square minus 3x square y square, and dou v by dou y is equal to 3, from here I can say 3x square y square. And from here, dou v by dou y will be equal to minus 9y square has to be equal to 0. Now you see second term and third term will cancel off. First and fourth also have to be cancelling off, which implies lambda has to be exactly equal to how much? 9. The correct answer, lambda equal to 9, option D will be correct over here. Okay, very simple equation, very famous equation. I hope it is clear till here to all of you. Moving further. Bernoulli equation represents total energy by which unit, he is asking. The standard form of Bernoulli equation is P by gamma plus V square 2G plus Z equal to constant, which is energy per unit weight form. Very famous term. Every term over there is a head. Units will be meter. Next question over here. Water is flowing through a pipe of diameter 8 centimeter under 40 Newton per centimeter square of pressure with a velocity of 3 meter per second. Mean velocity is 3 meter per second. What is a kinetic head? Now kinetic head is equal to how much? V square divided by 2G, which is equal to 3 square divided by G is 10, 20. 9 by 20 is equal to 0.45. So correct answer over here is 0.45 meter. Option D will be correct answer over here. Moving further. The question is saying Reynolds number is a ratio of inertia force to which force? Reynolds number is ratio of inertia force to viscous force. Very, very standard equation. Very, very standard term, Reynolds number. Moving further. The specific speed of a pump has what dimensions? Now this is a very important question. Recall specific speed of pump. Ns is equal to how much? It is equal to N root Q upon H power 3 by 4. 3 by 4. Okay. Now you see N over here, specific speed over here. n will have the units of second inverse or time inverse basically. Root q means meter cube per second whole power half. H power 3 by 4 is meter power 3 by 4. Meter power 3 by 4. So length is not mass is not existing over here. So this has to be mass power 0. Length power how much? Let us see. Ab you see over here, you are having over here meter cube hona chahiye. I'm sorry, this is meter cube. Meter cube power half, that is meter power 3 by 2 and meter power 3 by 4. I'll be having meter power 3 by 4 remaining. And the second power minus 1, second power minus half. So time power minus 3 by 2 will be remaining. So m power 0, L power 3 by 4, T power minus 3 by 2. L power 3 by 4, T power minus 3 by 2. Option A is correct over here. Okay, you can see option A is the correct answer. Next thing. Francis turbine is what kind of turbine? Very simple. Francis turbine is a reaction turbine. Kaplan and Francis both are reaction. And Pelton is a impulse turbine. Now next question, a Pelton wheel working under constant head and discharge has maximum efficiency. For efficiency maximum, the Pelton wheel is supposed to have the speed ratio of 0.5. Ab 0.5 is under ideal condition, but 0.5 is not possible. 0.5 is not possible. So now under actual condition, it will be approximately 0.46. Approximately 0.46. Next question. If three centrifugal pumps identical in all respects and each capable of delivering discharge Q against a head capital H are connected in parallel, the resulting discharge is equal to how much? All are connected in parallel, therefore their head will again be equal to H, but their discharges will get added up, therefore their discharge will be 3Q against the head of capital H. Next question. What will be the discharge of a single acting pump, reciprocating pump basically, which has one cylinder of area 0.5 meters square, stroke length of 20 centimeter, if the pump has a speed of 180 RPM? Very standard formula. The value is equal to A ln by 60. Very famous formula. Area over here is equal to 0.5. Length of stroke is given as 0.2 meter. N is equal to 180 divided by 60. So this becomes 3. So this becomes 0.1 into 0.3. Answer is supposed to be 0.3 meter cube per second. Answer is 0.3 meter cube per second. We have then option C over here is 0.3 meter cube per second. So these are the questions from the concept of fluid mechanics and hydraulic machinery. I hope the questions are clear to all of you.
Let's see questions from machine design. We have 3 questions here. So the first one is from the rivets. So here he is asking us to identify what is the relation between the diameter of rivet and the thickness of plate. We know that according to Unwin, the relation is D is equal to 6 root T. And here in this equation, we know that the thickness has to be greater than 8 mm. If thickness is greater than 8 mm, then only we need to make use of this simple relation. If thickness is less than 8 mm, we generally make use of the strength equations, which is, we know that the shear strength is equal to crushing strength relation. Using this, we tend to identify, so what is the diameter, nominal diameter or diameter required for a given thickness of plate. So here the answer is B. Moving to the next equation, which is from clutches. Here he is asking us to identify why cone clutches have become obsolete, which means we are not using these cone clutches. What is the reason here? So here in the options, we can notice that there is strict requirement of coaxiality of 2 shafts, which means we want both the shafts, the driving shaft and the driven shaft, to have coaxiality, which means they should be coaxial. If at all, if there is any deviation, yes, this will impact the operation. Okay, that will completely wear or damage the friction lining or the components. Because of that reason, yes, there is strict requirement of coaxiality. Yes, this is one of the primary reasons why I can say that so the cone clutches became obsolete. There is one more reason. If you notice, if the friction angle becomes or the coefficient of friction becomes more and more, what happens? Then the semi-cone angle, the friction becomes more and more. If the friction angle becomes more and more, then there arises a situation where there can never be disengagement of this clutch. It is called as self-engagement condition that can be avoided. So we can avoid that situation by keeping the friction lesser than the semi-cone angle. You might be knowing this simple condition. We can eliminate this by simple material conditions. Okay, that's the reason why this is not one of the primary reasons. But remember that if this is not present, if there is no coaxiality, yes, it can completely damage the operation. I can say that among these options that we have, yes, I can notice that option A is the most suitable answer for this question. Moving to the next one, the ratio of belt tensions. He gave that the ratio of tensions is given as T1 by T2 considering centrifugal force in flat belt drive. So he is asking us to identify. So we consider centrifugal force. Now here if you notice, when we are considering centrifugal force, the net tension here becomes equal to T1 minus mv square and T2 minus mv square. So here in the denominator it has to be T2, on the other side it is mu theta. Actually we know that T1 by T2 is equal to e power mu theta. Okay, and here we are adding centrifugal force, that's it. Okay, because of which there is loss of tension. Here we can notice that T1 minus mv square and T2 minus mv square. So this is the suitable answer for this question. Whereas here you can notice T1 by T2. So here there is no centrifugal force. Even though centrifugal force is considered here, he is considering it as e power minus mu theta. This is also wrong. This is also wrong. We know that the ratio of tensions is, he says that T2 is greater than T1, which is absolutely wrong. So this is also not true. So I can notice that the answer A here is right.
Welcome to ACE Online and ACE Engineering Academy. Myself, Madhushekar, faculty at ACE Online and ACE Engineering Academy. I am here going to discuss about the mechanical SSC JE mega mock test solutions, especially for production technology and material science. Now, especially for SSC JE, from the production technology and material science, on an average 15 to 20 questions they will ask you from all the topics of production including material science. Now some of the expected questions with the solutions I am going to discuss here. See, what does TIG in TIG welding stands for? See, for SSC JE the questions are very basic standard level. Out of 100 if you take, some 90 questions are very basic standard. Only if you have some basic fundamentals you will guess the answer. It is like time also is precious time. 1 minute, one question like that you should attempt. So that's why the basic questions here. What does TIG in TIG welding stands for? In TIG welding, the TIG represent tungsten inert gas. Okay, TIG represent tungsten inert gas. This is called TIG welding. Next, the primary shielding gas used in MIG welding. In MIG welding, the primary shield gas is either we can use argon or argon along with the carbon dioxide, we can use both. Okay, so argon we can use, argon plus carbon dioxide mixer we can use as a shielding gas. Next, cold shut. Cold shut is a casting defect actually. Okay, cold shut is a casting defect, that is incomplete fusion of two metal streams. Okay, so because of incomplete fusion of two metal streams, this type of defect you can see. Okay, now next, a metal billet of length 100 mm and diameter 50 mm is forged such that its length reduces to 80 mm. Okay, calculate the percentage increase in cross sectional area assuming constant volume. See, in the question, listen carefully, a cylindrical billet a cylindrical billet of initial length is 100 mm and diameter is D naught is 50 mm. Length is 100 mm, diameter is 50 mm. So this one, by applying two flat dies, they are going to compress so that you will get a final length that is going to be reduced L1 or LF you can take, that is 80 mm. Right? So we are going to compress the body like that. So what they are asking, percentage increase in cross-sectional area. See, in the question it is given a constant volume. So volume is constant, right? So for a constant volume, V is equal to constant, A naught, L naught is equal to AF, LF, right? So you can write A naught by AF is equal to LF by L naught, right? So percentage increase in cross-sectional area. Percentage increase in cross-sectional area. What is that increase in cross-sectional area? A naught minus AF by A naught into 100. Initial minus final by initial. Right. Right. So you will get negative here because initial area is less than final area, because here it is compressive force, area is going to increase in area. So I am not considering a sign. Okay. You can also write like this, AF minus A naught by A naught into 100. So you can write this one, AF by A naught minus 1 into 100. You can write this one, AF by A naught, you can write it as L naught by LF. So L naught by LF minus 1 into 100. So L naught is 100. This is 80 minus 1. Right? 10 by 8. You will get 10 by 8 or 5 by 4. You will get 125 minus 1. That is 25% you will get. So A is the correct answer for this question. Right? A is the correct answer for this question. Right. Now, next question. The question here it is, a billet of initial cross-sectional area of 1000 mm square is extruded to produce a profile of final cross-sectional area of 100 mm square. The extrusion ratio. Remember, extrusion ratio is what you know? That is initial area by final area. So initial area is 1000, final area is 100. So extrusion ratio is 10. So D is the answer for this question. Simple question. Next question. In orthogonal metal cutting, the cutting edge is oriented. In orthogonal metal cutting, the cutting edge is perpendicular to the cutting velocity. Cutting edge is perpendicular to the cutting velocity. Simple question. In CNC machining, G codes are used for, remember, in CNC machining, G codes are used for geometrical positioning of the tool. Okay, G codes are used for geometrical positioning of the tools. So B is the correct answer. Next, which type of milling involves the cutter rotating in the opposite direction to the feed of the workpiece? See, the cutter is rotating in the opposite direction to the feeding of the workpiece is up milling. So remember, in a simple way, the keyword you remember, opposite movement, up milling. same direction, down milling. Okay, na? Opposite is up milling. In the same direction, it is down milling. Right? Which factor mainly affects grinding wheel performance? Okay, like wheel hardness, grain size, bond type. 3 are given, right? So, all 3 depends, wheel hardness, grain size and bond. So, all 3 depends on the grinding wheel performance. Okay. Next, what is tempering in heat treatment? What is tempering in heat treatment? Remember, tempering is a secondary process applied after hardening process to relieve the hardening strains and to increase the toughness. So, increasing toughness means brittleness is going to reduce, right? Heating quenched metal after hardening to moderate temperature to reduce the brittleness and improve the toughness. So, B is the correct answer for this question. Next, which of the following types of stress-strain relationship best describes the behavior of brittle materials such as ceramics, thermoplastic, thermosetting plastics? See, ceramic materials, okay, they will not deform elastically and plastically. They will deform with a very little amount and at final point they will break. So that this is the correct answer for this question. D is the correct answer for this question, right? Next, the carbon content of mild steel. Remember, mild steel is a low carbon steel. Remember, mild steel is a low carbon steel. This low carbon steel consists of carbon from 0.008 to 0.25%. So, generally the mild steel is like 0.1215 like that. So, this is the correct answer for this question. A is the correct answer. Next, addition of magnesium and cerium to the grey cast iron. See, addition of magnesium and cerium to the grey cast iron, it convert into nodular cast iron. So, ductility will increase. So, graphite flakes are formed is wrong. This is wrong. Ductility increases and nodular graphite is formed. So, 2 and 3 are correct. So, B is the correct answer for this question, right? And sometimes they will also ask you to match the following questions. In the list 1, they are given the type of alloy, list 2 applications given. See, German silvers is a material used for plated jewelry. Alnico is a hard magnetic material used for magnetic applications. Monel metal is like used for frames of eyeglasses. Invar is used for surveying tapes. So, 3, 4, 1, 2, 3, 4, 1, 2. So, D is the correct answer for this question. 3, 4, 1, 2. D is the correct answer for this question. And one more question here is, the theoretical density of an FCC structure metal is rho, and atomic weight is A, and Avogadro's number is N, then the atomic radius is. So, remember, this is somewhat complex, but see here, for FCC structure, number of atoms are 4 inside the unit cell. R and A relation is 4R equal to root 2A. From this, lattice constant A equal to 4R by root 2, that you can write it as 2 root 2R, right? Volume of unit cell you can write A cube 2 root 2R whole cube, that is 16 root 2R cube we will get, right? So, theoretical density is what? Number of atoms into atomic weight by Avogadro's number into volume of unit cell, right? Volume of unit cell. So, I will substitute number of atoms for atomic weight A, Avogadro's number N I will take into volume of unit cell 16 root 2 R cube. So, this one 4. So, R equal to A by 4 root 2 R cube N whole power 1 by 3. So, here this is the C is the correct answer for this question. C is the correct answer. So, this type of question sometimes they will ask you, right. So, the way of asking questions are very easy and basic simple questions they will ask you. Now,
Let's see the solutions for this following questions. This is the first question we are having from SFD and BMD. A simply supported beam of length of 5 meter is subjected to a load of 5 kilonewtons, concentrated load at a distance of 3 meters from left support. For this condition, what is the maximum shear force in the beam? So, if I am taking the solution, this is a standard result. Again, we know the concept of a simply supported beam subjected to the eccentrically point load. Now, let us say this is A, this is B, and this is C, P. How much load is acting? That is 5. What is the span of the beam? L is 5 meters. And from left support, it is at a distance of 3 meters. I can say it is A equal to 3 meters and B equal to 2 meters. How do you calculate the reaction? So, usually we are using the concept of equilibrium. But here I am using the short trick. What is that? R1 equal to PB divided by L, R2 equal to PA divided by L. You can use this relation so that you are getting the reactions. What is the P value? 5 kilonewtons. B value is 2 meters. Length is 5. This is 2 kilonewtons. R1 is 2 kilonewtons and R2 if I am taking 5. What is A value? 3 upon 5. Strike off this one, you are having 3 kilonewtons. Obviously, in case of eccentric loading condition, the support which is very close to the point of application of the force is experiencing the maximum reaction. So, obviously, support B is very close to the loading location. So, here we are having the maximum reaction. So, what we required? We required the maximum shear force. Maximum shear force, let us say that is F. It is nothing but R2. If I am using the sign convention, basically here magnitude is given, but if I am using the sign convention, right hand side upward force is negative. So, minus R2 value how much? 3 kilonewtons. This minus and plus sign indicating the direction of the shear at a particular location, we know it. So, look at the magnitude. If I am taking the magnitude, 3 kilonewton is available at option C. So, which one is correct answer for this one? Option C is correct for this question. Hope it is clear to you. Now, one more question. This is from centered and moment of inertia. If the moment of inertia of your section about its base is 4000 units and the area of the given section is 10 units and the height of the neutral axis above the base, the distance between the neutral axis and the reference base is 10 units it is given. What we required? Its moment of inertia about the neutral axis, that is nothing but centroidal axis. So, to find out the moment of inertia about the neutral axis, here I am applying the parallel axis theorem, transfer formula. What it is saying, look at here, if I am taking the parallel axis theorem, apply the parallel axis theorem. I about the base is equal to I about neutral axis plus area of the given section and the distance, I can say this is gap, the distance between the reference axis and neutral axis, gap square. So, usually moment of inertia about the neutral axis or about the centroidal axis is having a least value comparatively other reference axis. Here it is 4000 means obviously option A, option B, undoubtedly they are incorrect answers. Either C or D is going to be correct answer. Let's see this one. I base, it is mentioned as 4000 units. I am using it here. And INA is our requirement. Area of the section is 10 units given and the distance between reference axis and neutral axis is mentioned as 10 square. So if you simplify this relation, you have the answer 4000 minus this is 1000. So 3000 units is the required answer. INA, it is a 3000 units. So which one is correct? Answer for this one is option C. Hope this is clear to you. Now one more question from bending stress analysis. The wire diameter is a D is wound around a cylinder. So I'm having a cylinder something like this. Just I am taking the sectional view. This is the cylinder. So one wire we are taking, it is a wounding around the cylinder something like this. Let's take something like this. Okay. And the cylinder diameter is mentioned as D means radius is D by 2. And the wire diameter, if I am taking this is the axis, you can consider axis, bending axis for the wire. Wire diameter, how it is? This is D units, wire diameter. Cool. What we require? The bending stress, maximum bending stress. Maximum bending stress is developed at extreme fibers, either a top fiber or bottom fiber. We know it. So we need to find out the sigma max. So sigma max we are getting from the bending formula. So take the bending formula first. From bending formula, M upon INA equal to sigma upon Y equal to E divided by R. So out of these 6 parameters, which information we are having from this one? So radius of curvature, if I am taking this one, let us take this is the radius of curvature R. R, it is nothing but D by 2 plus small d by 2. Being small d is very, very small comparatively capital D, I can get it is D by 2. R I know. Y also I know, na? Y it is nothing but maximum layer distance. Extreme layer distance from the neutral axis, from here to here or here to here. You can say this is D by 2. So I don't have any information about M. So I can use these two sets to get the sigma max. From this expression, sigma max equal to E, Y is becoming Y max, that is nothing but Y I am writing it here, R. Substitute the values. E is a material property, we know it. Y value, we are having D upon 2, okay. R value, D upon 2, capital D upon 2. This one is getting cancelled, huh? Then ED upon capital D. This is the required answer. So let us take this one, ED upon capital D, we are having at number B. So which one is correct? Option B is correct for this question. Hope it is clear to you. Let's move to the another solution. A rectangular beam section with depth 400 millimeter and a width 300 millimeter is subjected to a bending moment of 60 kilonewton meter. Then what we require, the maximum bending stress. Again, this is a bending stress formula we need to apply to get the solution. So let us take this is the rectangular cross section of the beam. What is B value? It is given as B value, it is 300 millimeter and depth it is given as 400 millimeter. Okay. How much moment is applied? 60 kilo Newton meter. So I am taking this in terms of Newton millimeter. Okay. Because geometrical dimensions we are having in millimeters. What we required sigma max. Directly I am using this formula. From bending formula, after simplification for rectangular cross section, it is 6m divided by BH square. I know sigma max is nothing but m upon ZNA. ZNA is the section modulus, we know it. For rectangular cross section, section modulus is BH square upon 6. This I am using it here. One side we have the tensile behavior, other side we have the compressive behavior stress. But here we have only magnitudes, focus on magnitudes rather than the behavior. What is the moment value? 60 into 10 to the power 6. Na? B value is 300, H value is 400 square. I am writing something like this. 1, 2, 3, 4, 5, 6 zeros are getting cancelled. 3, 2 times we are having. 2 twos are, you can say 4 15s are this one. 4 15s are we are having now. And this is 2 times we are having 15 upon 2, 7.5 na megapascal. 7.5 megapascal is the required answer. Look at the options. Yes, we are finding it at option A. Which one is correct? Option A is correct for this question. Hope it is clear. Yes, this is a theory based question from torsion. A shaft of circular section is subjected to the pure torsion. So, shaft is under pure torsion when it is subjected to the equal and opposite end couples whose axis coincides with the, see the 4 options. So, normal line to the axis of the shaft. That means when I am taking the reference as the axis, it is normal to the lines are, couple lines are, it is normal to the axis of the shaft, it is parallel to the axis of the shaft. Any line passing through the section of the shaft, that means any oblique line it is. The 4th one is axis of the shaft. So, as we know, when we have equal and opposite end moments, if I am using it about the longitudinal axis, then it will generate the torsion. We know it. When we are applying the moment about the longitudinal axis of the member and that is going to be resisted at other end, it will generate the torsion. Torsion, one kind of angular deformation we are observing in the members because of application of the moment about the longitudinal axis. This is the longitudinal axis. That means when this couple axis is coincides or when it is a parallel to the axis of the shaft, when I am rotating it, the cross section is rotating something like this about the longitudinal axis of this particular member, then torsion generate. That means at the time of applying the couples, this couple axis is going to be parallel to the longitudinal axis of the member. So, obviously option B is correct for this particular question. Hope it is clear. See the next one. This is from columns. The safe compressive load on a hollow cast iron column, one end is fixed and other end is hinged of 150 mm external diameter and 100 mm internal diameter and 10 meter length is, we need to find out the safe load. So, safe load, how I am getting this one? Failure load divided by factor of safety. So, to find out the failure load, which one we need to use here? Euler formula, that is clearly mentioned, Euler formula. So, Euler formula is used to find out the buckling load. So, safe load, it should be equal to buckling load or critical load divided by factor of safety. N is the factor of safety. N is the factor of safety. Factor of safety, how much it is given? 5. So, my target is first finding this one, PB. So, how you get the PB? Use the Euler formula. Euler formula, if I am taking this one, this is pi square E I min divided by LE square. What is the end condition it is given? One end is fixed, other end is hinged. Try to get the LE value for this condition. LE, if I am taking this one, LE value if I am taking this one, L divided by root 2, one end fixed, other end free connection. Sorry, other end hinge connection. Other end hinge connection. Okay, we know it. That is clear. Apply this condition. So, everything is known. I, it is a circular, hollow circular cross section. I value, it is pi upon 64. About x and about y, both are equal values only. Pi by 64, d naught to the power 4 minus di to the power 4. So, pi divided by 64. So, external diameter is 150, internal diameter is 100. 150 to the power 4 minus 100 to the power 4. E value already mentioned 95 giganewton per meter square. If I am taking E in terms of megapascal, 95 into 10 cube. 10 cube megapascals we are having. Okay. Everything is known, just you substitute all the values and simplify, you are getting the answer. PB, pi square, E value is 95 into 10 cube, and I value, this is the I value we are having, pi upon 64, 150 to the power 4 minus 100 to the power 4. Okay, LE value is, what is L value? L value, it is given as 10 meters. You can take that in millimeters. 10 into 10 cube. 10 into 10 cube millimeters. I am taking this. Okay. Now you can take this L value divided by root 2 is there. So 10 meters, if I am considering in millimeters, 10 into 10 cube divided by root 2 whole to the power square we are having. If I am simplifying, I am getting the PB. From PB, just look at here, we require the safe load, apply that value. We require the safe load. Safe load, it is nothing but PB divided by factor of safety. How much it is given? Factor of safety, it is given as 5 units. You can substitute. Then we have the P value in newtons, that you try to convert into kilonewtons, because options we have in kilonewtons might be, the option is option A is correct for this question. Simplify it. This is numerical oriented, we know it. Just you can simplify. You have the answer is option A. Hope it is clear to you.
Dear students, here we welcome you to the mock of SSC JE. So first question from the subject theory of machines, that is moment of inertia of the flywheel is given as 1000 kg per meter cube, sorry 1000 kg meter square, and it starts with uniform acceleration of 1 radian per second. The value of alpha is 1 radian per second square, and after 20 seconds the kinetic energy will be dash. So omega will be equal to alpha times of t, so that is alpha, and the time duration is 20. So this is equal to alpha is 1 into 20, which is equal to 20 radians per second it would be, and kinetic energy is given by Ke is equal to 1 by 2 times of I omega square. So this is 1 by 2 into I is 1000 into 20 square. So this is equal to, this is 20 square is 400, 400 by 2 is 200, 200 into 1000, that is 200, or 2 into 10 power 200 into 1000 it would be, which is also 200 kilonewton meter of energy will be possessed by the flywheel. That is option D is the answer. In the next question, it is asked to compute the mobility of the mechanism. So here is the question. So this is link number 1, that is fixed. This is link number 2, link number 3, link number 4, link number 5, and link number 6. So number of links we have got is 6. Number of joints, this is J1, this would be J2, this would be J3, J4, J5, J6, and 7 as well. So number of joints will be equal to 7. Degree of freedom, that's equal to 3 into 6 minus 1 minus 2 into 7, which is equal to 1. Degree of freedom will be equal to 1. That's option B is the answer. In the next question, two gears meshing have pressure angle of 20 degrees and are used to obtain a gear ratio of 22.25, and the wheel that has 80 teeth and 3 mm module. The number of teeth on pinion of the wheel on the pinion is, that is ZP by ZG, which is equal to ZP by 80. This is equal to 0.25 it is, that is reduction ratio. So ZP is equal to 0.25 into 80 is 20. So 20 number of teeth are required to be there on the pinion. Option A is the answer. In the question, it says about isochronous governor, the equilibrium speed is dash. So isochronous is a theoretical condition. So irrespective of the radius, if r is variable,
R is variable, if R keeps changing, the omega is going to be constant. Omega is constant. So here it says that equilibrium speed is same for all radii of rotation. This is the property. Okay. So option B is the answer.
Hello dear students, welcome to the ACE online platform. Now we are going to discuss the solutions for questions given from thermal part. Okay, first let us take the thermodynamics part. Okay, look at the very first question. It is asking like this: air is compressed in a cylinder such that the volume changes from 0.2 meter cube to 0.02 meter cube. Means initial volume V1 equal to 0.2 meter cube and final volume V2 equal to 0.02 meter cube. Okay. The initial pressure is 200 kilopascal. Initial pressure P1 equal to 200 kilopascal. If pressure is constant, pressure constant means P2 equal to P1, that is equal to P. The approximate work is, you are asked to decide the work at constant pressure. As you know, the work at constant pressure is equal to simply P into V2 minus V1. Substitute the values. P is 200 kilopascal multiplied by V2 0.02 minus 0.2. You simplify this value for getting minus 36 kilojoules. That is the answer. Okay, understood clearly? Yes. Look at the option A. Option A is absolutely correct. Okay. Similarly, look at the another question. If the value of n is 0 in the equation PV power n equal to constant, the polytropic rule is given as PV power n equal to constant. Given that n value equal to 0, polytropic index n equal to 0, then the process is called, what is the name of the process if polytropic index n equal to 0? Let us put this value in the relation PV power 0 equal to constant. Anything power 0 equal to 1 only, then this is P into 1 is equal to constant. Indirectly, it is a constant pressure process. That means the polytropic index n equal to 0, the process name is constant pressure process. Look at the B. Option B is absolutely correct. Okay, understood clearly? Yes. Similarly, look at the another question. A polytropic process with n equal to -1. The polytropic index small n equal to -1 with P equal to V equal to 0. That means initial pressure P1 equal to 0 and initial volume V1 also equal to 0. And ends with P means final pressure P2 equal to 600 kilopascal and final volume V2 equal to 0.01 meter cube. The work done you are asked to decide. As you know, the work done for a polytropic process is P1 V1 minus P2 V2 dividing by n minus 1. P1 is 0, V1 also 0, minus P2 600 into V2 0.01 dividing by n is minus 1 minus 1. It is equal to minus 600 into 0.01, that is 6, minus 6 divided by minus 2. Minus 6 divided by minus 2, minus cancel, it is 3 kilojoules. That is the answer. Look at the option B. Option B is absolutely correct. Very simple problems. Okay. Similarly, look at the another question. the change in enthalpy of a closed system is equal to the heat transfer if the reversible process takes place at constant pressure. Dear friends, remember, the amount of heat transfer at constant volume is equal to change in internal energy, whereas the amount of heat transfer at constant pressure is equal to change in enthalpy. Once again, the amount of heat transfer at constant pressure equal to change in enthalpy, whereas the amount of heat transfer at constant volume is equal to change in internal energy. It is given that the change in enthalpy of a closed system is equal to heat transfer. That means change in enthalpy equal to heat transfer at constant pressure only. Look at the option B. Option B is absolutely correct. Are you following clearly? Yes. Similarly, look at the another question. An engine operates between temperature limits of 900 Kelvin and T2. That means initial temperature T1 equal to 900 Kelvin. The temperature right at the exit of the engine T2 equal to T2 only. T2 equal to T2. And other engine operates between T2 and 400 Kelvin. It is like this. The arrangement is like this. This is the heat engine 1, and this is the heat engine 2. For the heat engine 1, temperature limits given. This is the hot source. Maintaining the temperature T1 is given 900 Kelvin. 900 Kelvin. The hot source is supplying the heat energy. A part of the heat energy is converted to work energy. The remaining heat energy is dumped to the intermediate source. For that intermediate source, the first heat engine is dumping the heat equal to Q2, while the intermediate source is maintaining T2 temperature. Whereas the second heat engine is operating between T2 and 400 Kelvin. It means second heat engine is receiving Q2 amount of heat energy from the intermediate source. A part of the heat energy is converted to work energy. The remaining energy is dumped to the cold source. This is the cold source. The amount of heat dumped to the cold source is Q3 while it is maintaining the T3 temperature. That T3 is given as 400 Kelvin. 400 Kelvin. That means series arrangement of the Carnot heat engines. Okay. For both engines to be equally efficient, T2 should be. Dear friends, remember, for equal efficiency, it means efficiency of the first heat engine equal efficiency of the second heat engine. The intermediate source temperature T2 equal to root over T1, T3. Okay. Whereas for equal work output, it means work given by the first heat engine is equal to work given by the second heat engine. For this condition, the intermediate source temperature T2 equal to arithmetic mean between the T1 and T3. T1 plus T3 by 2. Okay. But given problem is for equal efficiency. Equal efficiency means efficiency maintained by the first heat engine and efficiency maintained by the second heat engine. Both are equal. For that case, the intermediate source temperature T2 equal to root over T1, T3. T1 is 900 Kelvin multiplied by T3, 400. You simplify this value for getting the intermediate source temperature is 600 Kelvin. Understood clearly? Now look at the options. Option A itself is absolutely correct. Okay, now? Shall I move to next one? Yes. Look at the another one. The more effective way of increasing efficiency of Carnot engine is, efficiency of the Carnot engine equal to 1 minus lowest absolute temperature by highest absolute temperature. From that you can conclude that the efficiency of the Carnot cycle can be increased by increasing the highest absolute temperature at constant lowest absolute temperature. This is the one option for you. The other option is decreasing the lowest absolute temperature at constant highest absolute temperature. The other more effective way is by increasing the highest absolute temperature and by decreasing the lowest absolute temperature. So efficiency of the Carnot cycle can be increased by either increasing the higher temperature at constant lower temperature or decreasing the lower temperature at constant higher temperature. And the most effective method is by increasing the highest absolute temperature and decreasing the lowest absolute. But if you ask me, among the first two cases, which is a better way? Definitely by decreasing the lowest absolute temperature, efficiency of the Carnot cycle can be increased in the better manner. Now look at the options. Increasing of source temperature, no. Decreasing of source temperature, no. Increase of single temperature. This called lowest temperature is also called single temperature. Decreasing of single temperature, absolutely correct. So of course, by increasing the highest absolute temperature, efficiency can be increased. But if you increase the same amount of temperature and decrease the same amount of temperature, definitely the efficiency can be increased in the better manner by decreasing the lowest absolute temperature than by increasing the highest absolute temperature. Therefore, option D is absolutely correct. Okay, na? Similarly, look at the next question, asking like this: the device that produces network in a complete cycle by exchange heat only with a single thermal energy reservoir is known as, according to Kelvin Planck statement or according to second law of thermodynamics, at least two thermal reservoirs are required for constructing any heat engine. That means one thermal reservoir for supplying the heat, other reservoir for receiving the heat. Though you are selecting the three thermal reservoirs, at least one thermal reservoir is for supplying the heat and at least one thermal reservoir for receiving the heat. That means for constructing any heat engine like petrol engine, diesel engine or thermal power plant or gas turbine power plant, at least two thermal reservoirs are required. But it is given that a heat engine is heat engine is constructed to work with a single thermal reservoir. That is like this. This is the heat engine. Imaginary heat engine is receiving the heat from single thermal reservoir. It is completely converting, right, work energy. That means W equal to Q. Means indirectly the complete low grade energy is converted high grade energy. This kind of engine cannot be practically possible. Of course, this kind of engine you can call as PMM2, perpetual motion machine of second kind. An imaginary heat engine which works with only one thermal reservoir is called PMM2. Dear friends, remember, PMM2 is not practically possible. If it is possible, Kelvin Planck statement violates or second law of thermodynamics violates. Because, the heat rejection from this engine Q2 equal to 0. Q2 equal to 0. Then what is the efficiency? Efficiency of the PMM2 equal to work output by heat input. Since work output and heat input both are equal, it maintains 100% efficiency. But practically, no heat engine can maintain 100% efficiency because heat engines are working with the low grade energy. Low grade energy cannot be completely converted to high grade energy. Anyhow, a fictitious heat engine which is constructing to work with only one thermal reservoir can be called as PMM2, perpetual motion machine of second kind. That kind of heat engine cannot be practically existing. Anyhow, look at the options. PMM3, no. PMM2, correct. A heat engine which is working with only single thermal reservoir is called PMM2. Okay, na? But not practically possible. If it is possible, second law of thermodynamics violates. Understood clearly? Yes. Similarly, look at the another question asking like this: A heat engine develops 60 kilowatts of work having efficiency 60%. Amount of heat rejection will be, given that a heat engine develops 60 kilowatts of work. Work given by the heat engine 60 kilowatts. While it is maintaining the efficiency of the heat engine equal to 60%. What is the heat rejection? QR equal to how much? Very simple problem. As you know, the efficiency of the heat engine equal to work output by heat supplied. From this heat supplied equal to work output by efficiency of the heat engine. Work output is 60 dividing by 0.6. 60 divided by 0.6 equal to 100 kilowatts. That is the heat supplied. But you know, work equal to what? Heat supplied minus heat rejection. From this, the heat rejection QR equal to QS minus work. Heat supplied found 100 kilowatts minus work output given 60. 100 minus 60 is equal to 40, that is 40 kilowatts. That is the amount of heat rejection. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another question. Look at this one. Asking like this. When a system undergoes a process such that integral dq by t equal to 0, integral dq or del q by t equal to 0. It means indirectly dq equal to 0. That means heat transfer 0. If the heat transfer is 0 for any process, that process you can call as adiabatic process. Okay, and delta S greater than 0. That means total change in entropy. The total change in entropy delta S greater than 0. As we all know, the total change in entropy delta S equal to del Q by T plus S generation. This S generation or S gen is the entropy generation due to internal irreversibility. Dear friends, remember this entropy generation always greater than or equal to 0. Okay, remember this entropy generation equal to 0 for a reversible process, and entropy generation greater than 0 for irreversible process, and remember entropy generation less than 0 impossible. That means entropy generation never be negative. Entropy generation may be equal to 0 for reversible process but more than 0 for irreversible process. But given condition is del Q 0, that means this part is given 0, then delta S equal to S generation only. This delta S given greater than 0 means entropy generation greater than 0. If the entropy generation is greater than 0, the process is called as irreversible process. Therefore, the process name is irreversible adiabatic process. Look at the option C. Option C is absolutely correct. Understood clearly? I am trying to explain the each and every point at your understanding level. Okay na? Similarly, let us take the another question. It is asking like this. The irreversibility associated with the process is defined as option A, loss of qualitative energy, option B, loss of energy, option C, loss of enthalpy, option D, loss of entropy. Dear friends, remember, because of the irreversibility, quality of the energy always decreasing. Therefore, option A is correct. You know, first law of thermodynamics is talking about the quantity of the energy. Second law of thermodynamics is talking about the quality of the energy. That's why Second law of thermodynamics is also called law of degradation of energy. First law says that the total energy in the universe remains constant. Second law also agreeing that, okay, total energy in the universe remains constant, but the quality of that total quantity of the energy keep on degrading. That's why second law of thermodynamics is also called law of degradation of energy. So first law is speaking about the quantity of energy, whereas second law of thermodynamics is speaking about the quality of the energy. Because of the irreversibility, quality of the energy always degrading or decreasing. Therefore, selected option A. Okay. Similarly, look at the another problem. For a steady flow process, the conditions at stage 1 and stage 2 respectively are. Stage 1 means state 1. Given enthalpy H1, let me write it. H1 equal to 300 kilojoules per kilogram and H2 equal to 150 kilojoules per kilogram. S1 entropy at state 1, S1 is 1.25 kilojoules per kilogram Kelvin and entropy at state 2 given 0.8, S2 equal to 0.8 kilojoules per kilogram Kelvin. The availability at the ambient temperature will be, ambient temperature is not given. For the availability concept, if the ambient temperature is not given, you take 300 Kelvin, T0 equal to 300 Kelvin, that is the ambient temperature. Then availability, 1 minute, availability is equal to H1 minus H2 minus T0 into S1 minus S2. S1 minus S2. Okay. So H1 equal to 300 minus 150 minus T0 300 into S1 1.25 minus 0.8. Simplify it for getting around 15 kilojoules. That is the answer. That is the availability of this particular problem. Right? Option A is absolutely correct. Understood clearly? Yes. Similarly, look at the another question. A positive value of Joule-Thomson coefficient of a liquid means, as we all know, Joule-Thomson coefficient mu Jt equal to dou T by dou P at constant enthalpy. Since enthalpy remains constant for any throttling process, the throttling process can also be called as isenthalpic process. Dear friends, remember, the throttling process is for dropping the pressure. That too, the pressure is dropping in the throttling process due to friction. That means frictional pressure drop is happening in the throttling process. That means dou P always negative. Dou P always negative means pressure of the fluid decreasing in the throttling process. This is always negative. Next, it is given that Joule-Thomson coefficient is positive, the positive value of Joule-Thomson coefficient. The mu Jt, Joule-Thomson coefficient will become positive only when dou T is negative. Dou T negative means temperature is decreasing. When dou T is negative, dou P also negative, Joule-Thomson coefficient is positive. It means indirectly temperature decreases. That means the Joule-Thomson coefficient positive means the temperature of the material decreases. That kind of process you are calling as cooling process. It means for the cooling process, right, that means Joule-Thomson process or throttling process is happening by the combined effect of warming and cooling. The Joule-Thomson coefficient is negative for the warming process and is positive for the cooling process. For the warming process, dou T positive. Dou T positive means temperature is going to increase. When dou T is positive, dou P always negative, Joule-Thomson coefficient negative. Joule-Thomson coefficient negative means that is the warming process. Joule-Thomson coefficient positive means that is the cooling process. Cooling process means temperature of the working material decreases, whereas warming process means temperature of working material increases. Anyhow, it is given that positive value of Joule-Thomson coefficient is happening with decrease in temperature of the material. Look at the option A. Temperature drops during the throttling, correct? Temperature remains constant? No. Temperature rise during the throttling? No. None of the above. So during the throttling process, if temperature is dropping, then only Joule-Thomson coefficient mu Jt is positive. Understood clearly? Yes. Similarly, look at this one. The specific heat of gas remains constant at all pressures and temperatures. This pertains to, according to Rignall's law. Rignall's law states that the ratio between the two specific heats, namely specific heat at constant pressure and specific heat at constant volume, remains constant. That constant is called adiabatic index. Anyhow, the Rignall's law is speaking about the ratio between the two specific heats or adiabatic index. And remember, for any ideal gas, the specific heats are remaining constant. That means irrespective of the pressure and temperature change, the ideal gases can maintain constant specific heats. Rignall's law is the one of the ideal gas laws. Option B is absolutely correct. Okay, now similarly, look at the another question asking like this: the value of dryness fraction at critical point for water steam phase transformation may be. If you look at the TS diagram, temperature versus entropy diagram for the pure material, the saturation dome is appearing like this. That is how the saturation dome is appearing. This particular curve is called saturated liquid curve. Saturated liquid curve. Dear friends, remember, along the saturated liquid curve, dryness fraction x equal to 0. Whereas the other side curve, this is the saturated vapor curve. Saturated vapor curve. Along the saturated vapor curve, dryness fraction x equal to 1. That means dryness fraction value varying from 0 to 1. The apex point is representing the critical point. Critical point means the point where the saturated liquid is directly transferred to supercritical material without having the observable phase change. At this critical point, density of the saturated liquid equal density of the saturated vapor. That means there is no phase distinction between the saturated liquid and saturated vapor at critical point. At this critical point, dryness fraction cannot be defined. It means dryness fraction is indeterminate at a critical point, right? Now it is asking the value of dryness fraction at critical point is undefined. Option D is absolutely correct. Okay, understood? Yes. Similarly, look at the other one. It is asking like this. On Mollier chart, the slope of an isobar means constant pressure line on HS diagram is equal to where T is the absolute temperature. As you know, enthalpy H equal to U plus PV. U plus PV. dH equal to what? du plus PdV plus VdP. VdP. Here the du plus PdV, dH equal to du plus PdV I can write as del Q plus VdP. Plus VdP. Right now dH equal to, for a reversible process, this del Q I can write as TdS. TdS plus VdP. VdP. For a constant pressure process, what is the dP value? For a constant pressure process, dP equal to 0. This part is becoming 0. Then dH by ds at constant pressure is equal to T. The quantity dH by ds at constant pressure is the slope of constant pressure line, right? In the Mollier diagram is also called HS diagram, that is equal to absolute temperature. Look at the option C. Option C is absolutely correct. Understood clearly? Dear friends, remember the quantity dH by ds at constant pressure is the slope of isobaric line or isobar with the Mollier diagram or HS diagram. I hope all of you clearly understood. With this, thermodynamics part will be completed. Understood clearly? Yes. Dear students, now let us discuss the solutions for the power plant engineering questions. Okay, look at the first question from the power plant engineering, asking like this: in a simple turbine, the nozzle angle at the entrance is 30 degrees. Nozzle angle you can mark as alpha equal to 30 degrees for the simple impulse turbine like D level turbine. D level turbine is the simple impulse steam turbine, like how the Pelton wheel is the simple impulse water turbine. What is the blade speed ratio for maximum diagram efficiency? That means indirectly you are asked to decide what is the optimum blade speed ratio, because at optimum blade speed ratio the D level turbine can maintain its highest efficiency. Of course, the Parsons turbine or reaction turbine, each and every turbine is maintaining its own optimum blade speed ratio. At that optimum blade speed ratio, that turbine can maintain the highest efficiency. Since it is given for the simple impulse turbine, for the simple impulse turbine like D level turbine, optimum blade speed ratio U by V1 equal to cos alpha by 2. Cos alpha by 2. It is equal to cos alpha 30 degrees dividing by 2. Cos 30 degrees equal to root 3 by 2 into 2. That means it is equal to root 3 by 4. You simplify this value for getting 0.433. Simplify that value for getting 0.433. That is the answer. Understood clearly? Yes. Similarly, look at the another one. It is asking like this: total enthalpy of steam at the inlet of nozzle is 2800 kilojoules per kg. Let me mark the nozzle. This is the nozzle. Somewhere here the steam is entering with enthalpy H1 given 2800 kilojoules per kg, and at exit it is given 2500. Total enthalpy of the steam at the outlet, that I can mark as H2 equal to 2555 kilojoules per kg. What is the steam velocity at the exit if the expansion is isentropic? That means if the steam is expanding through the nozzle reversible adiabatically, for that it must be perfectly insulated. Once it is insulated, the heat transfer is 0. Heat transfer 0 means adiabatic process. If there is no internal irreversibilities for that process can be called as reverse adiabatic process. The reverse adiabatic process is also called isentropic process. Anyhow, if the steam is expanding isentropically, the exit velocity C2 equal to 44.72 into root under H1 minus H2. It is equal to 44.72 into root under H1 2800 minus 2555. You simplify this value for getting approximately 700 meters per second. That is the exit velocity of the steam. Therefore, option D is absolutely correct. Understood clearly? Yes. Similarly, look at the other one. Which one of the following is the fire tube boiler? Babcock and Wilcox boiler, it is the water tube boiler. Locomotive boiler, fire tube boiler. Stirling boiler, water tube boiler. Benson boiler also water tube boiler. Among these four boilers, locomotive boiler is coming under fire tube boiler. Option B is absolutely correct. Okay. Similarly, which one of the following statement is correct? The degree of reaction for a simple impulse turbine. For simple impulse turbine, the degree of reaction is equal to 0, because the impulse turbines are constructed such that to expand the steam at constant pressure. Since the pressure of the steam remains constant by the time the steam is expanding over the impulse turbine blades like a D level turbine, there is no change in enthalpy. The degree of reaction RD equal to what? The degree of reaction RD equal to enthalpy drop in the mobile blade dividing by enthalpy drop in the fixed blade plus enthalpy drop in the mobile blade. This summation I can also write enthalpy drop per stage. Anyhow, for the impulse turbine like D level turbine, there is no pressure drop Therefore, enthalpy drop in the movable blade is 0. 0 by something is 0 only. Therefore, degree of reaction for simple impulse turbine like D-level turbine is 0. Whereas for the pure reaction turbine like Hero turbine, the degree of reaction is 100%. Whereas 50-50, that means 50% reaction turbine, that is Parsons turbine. For Parsons turbine, degree of reaction is 0.5. Okay. Anyhow, since it is given for simple impulse turbine, for the simple impulse turbine, degree of reaction equal to 0. Right. Similarly, look at the other one. Blade erosion in steam turbine takes place due to high temperature? No. Due to droplets in steam? Yes. Because of the moisture particles in the steam, the blades may be damaged by erosion and corrosion. Option B is correct. Okay. Similarly, look at the other one. Consider the following: injector, economizer, blow-off cock, steam stop valve. Which of the above are boiler accessories? You know, a blow-off cock is the boiler mounting. Steam stop valve also boiler mounting. Whereas the injector, steam injector is the boiler accessory, and economizer also boiler accessory. Anyhow, the steam injector and economizer both are coming under boiler accessories. 1 and 2, option B is absolutely correct. Are you following clearly? Yes. Similarly, look at the other one. Which one of the following is proper for normal shock wave? Because of the normal shock wave, the irreversibilities are developed, right? Because of the normal shock wave, steeply or irreversibly, the pressure rises rapidly happening. That kind of rapid pressure rise you can treat as irreversible process. So normal shock, wherever the normal shock wave is developing, there the irreversibilities developed are more. Therefore, you can select the option B. Okay. Similarly, look at the other one. Which one of the following statements is correct? In a boiler, the air preheater is invariably located between, in a boiler, air preheater is placed between the forced draft fan and furnace. In between the forced fan and the furnace, the air preheater is connected. Air preheater is coming under one of the accessory where the air is getting preheated before it is supplied to the combustion chamber or furnace by utilizing the heat energy from the waste flue gases. Okay. Anyhow, that air preheater is placed between forced draft fan and furnace. Option B is absolutely correct. Okay. Are you following? Yes. Similarly, look at the other one. Which of the following is a boiler accessory? Water level indicator, it is the mounting, boiler mounting. Steam injector, this is a boiler accessory. Feed check valve is a boiler mounting, and pressure gauge also boiler mounting. Since it is asking for boiler accessory, steam injector is coming under boiler accessory. Remaining 3 are boiler mountings. Okay. Similarly, look at the other one. Consider the following: blow-off cock, steam stop valve, fusible plug, steam injector. Which of these are boiler mountings? Blow-off cock is the boiler mounting. Steam stop valve also boiler mounting. Fusible plug also boiler mounting. Whereas steam injector is the boiler accessory. Since it is asking for mountings 1, 2, 3, look at the 1, 2, 3. Option C is absolutely correct. Blow-off cock, steam stop valve, fusible plug. These 3 are coming under boiler mountings. Okay. Similarly, look at the other one. If the nozzle efficiency is reduced to half of its value, then nozzle velocity coefficient. As you know, the nozzle velocity coefficient CV, nozzle velocity coefficient CV equal to the ratio between the actual velocity, that is V2 dash, and ideal velocity V2. But what is the actual velocity? Actual velocity is 44.72 into root under actual enthalpy drop dH dash dividing by the ideal velocity. Means if the steam is expanding reversible adiabatically, whatever the velocity maintained by the steam at the exit is the ideal velocity, that is equal to 44.72 into root under dH. Finally, it is equal to coefficient of velocity V2 CV equal to actual exit velocity by ideal exit velocity, that is equal to root over, this part is cancelled, dH dash by actual enthalpy drop by ideal enthalpy drop. As we know, the ratio between the actual enthalpy drop and ideal enthalpy drop is the nozzle efficiency. It is equal to root over nozzle efficiency. Here nozzle efficiency, it is like this. Let us take the Mollier diagram, also called HS diagram. In the Mollier diagram, the saturated vapor curve is appearing like this. This is the critical point. This is the critical point. Right? Now, let us take the pressure of the steam while it is entering to the nozzle. That is the P1. This is the pressure of the steam while it is leaving from the nozzle. P2. The steam is generally entering to the nozzle under superheated condition with the temperature T1. Wherever the P1 and T1 are meeting, that is the initial state of the steam while it is entering to the nozzle. If the steam is expanding isentropically, the isentropic expansion is marked as, right, 1, 2, 2. For that isentropic expansion process, look at the enthalpy drop. Enthalpy drop is from H1 to H2. H1 to H2. The ideal enthalpy drop equal to H1 minus H2. But once we consider the internal irreversibilities, the curve is deviating towards the increase in entropy. The 1 to 2 dash is the actual expansion. After actual expansion, look at the enthalpy of the steam, H2 dash. Then actual enthalpy drop, dH dash equal to H1 minus H2 dash. Then the ratio between this actual enthalpy drop and ideal enthalpy drop is called nozzle efficiency or utilization factor of the nozzle. So that is how you can define the nozzle efficiency. Your actual enthalpy drop dividing by ideal enthalpy drop is the nozzle efficiency. That's why this dH dash by dH I wrote as nozzle efficiency. So conclusion is coefficient of velocity CV equal to root over nozzle efficiency. Then it is asking that if the nozzle efficiency is reduced to half of its value, that means CV dash is equal to root over nozzle efficiency decreases half, nozzle efficiency dividing by 2. It is equal to what? 1 by root 2 into root over nozzle efficiency. What is the 1 by root 2? Root 2 value? Root 2 value is 1.414 now. Root 2 value equal to 1.414. Therefore, if the nozzle efficiency is decreased by half, its velocity decreases by 1.414 times. So anyhow, option B can be selected. Understood clearly? Yes. Similarly, look at the another one. In a two-stage reciprocating compressor, the suction pressure and delivery pressure respectively are, suction pressure I can mark as P1 equal to 1 bar and delivery pressure can be marked as P3 equal to 25 bar for the single stage reciprocating compressor, right? In a two stage, not single stage, two stage. The two stage reciprocating compressor arrangement is like this. This is the low pressure compressor, this is the high pressure compressor. High pressure compressor. This is the low pressure compressor. In between the high pressure and low pressure compressor, there is a heat exchanger you can call as intercooler. Now for the low pressure compressor, the local atmospheric air is entering with a pressure P1. Because of the compression in the low pressure compressor, pressure increases from P1 to P2. At this P2, constant pressure P2, the compressed air is rejecting the heat to the coolant available in the cooler or intercooler. So because of that cooling, at constant pressure, temperature decreases, but still the pressure at state 3 is P2 only. With that pressure P2 and low temperature, air is entering to high pressure compressor where the pressure is further increasing to state 4 pressure, that is P3. So the air is entering with a pressure P1, that is 1 bar. Air is leaving from the two-stage compressor with 25 bar. For maximum efficiency, the intercooler pressure is. That means indirectly you are asked to decide what is the optimum intercooler pressure. Optimum intercooler pressure is geometric mean between the P1 and P3, root over P1, P3, right? So it is equal to root over 1 into 25 is equal to 5 bar. That is the optimum intercooler pressure, right? 5 bar. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, look at the other one. Which one of the following is characteristics of the Brayton cycle? Brayton cycle means the cycle used for constant pressure gas turbine power plant. For the Brayton cycle, heat addition and heat rejection both are taking place at constant pressure. Dear friends, remember both Brayton cycle and Rankine cycle both are maintaining same number of process and same types of process. But the difference is for the Brayton cycle, gas is the working material, whereas vapor is the working material for the Rankine cycle. Anyhow, for both Brayton cycle and Rankine cycle, heat supplied at constant pressure and heat rejection at constant pressure. Anyhow, it is given for Brayton cycle. For Brayton cycle, isobaric heat addition absolutely correct. Isothermal heat release not correct. Isochoric heat addition not correct. Isothermal heat addition not correct. So for the Brayton cycle is also called Joule cycle. Heat addition and heat rejection takes place at constant pressure. Isobaric process means constant pressure process only. Therefore, option A is absolutely correct. Understood clearly? Yes. With this, my dear students, the questions from the power plant completed. Okay? Na? Yes. Dear students, now let us discuss the solutions for questions given under refrigeration and air conditioning. Okay, look at the first question from refrigeration part. Temperature near absolute zero are obtaining by using, absolute zero state means the state where the molecular momentum is zero is called absolute zero state. At that absolute zero state, temperature is called absolute zero temperature and corresponding pressure is called absolute zero pressure. If we measure the temperature based on that absolute zero state, that temperature is called absolute temperature. That absolute temperature capital T equal to thermometer reading in degree centigrade plus 273.15. The resulting unit is Kelvin. That means if you decrease the temperature to minus 273.15 degree centigrade, at that particular temperature, the molecular momentum is zero. That particular state is called absolute zero state. The temperature is called absolute zero temperature. That absolute zero state is obtained by magnetic cooling mechanism. Therefore, option D is absolutely correct. Okay, na? Similarly, look at this one. The preferred relative humidity in an air conditioned space for the human occupancy. Dear friends, remember, the year-round comfortable temperature is varying from 18 to 24 degrees centigrade and the relative humidity, comfortable relative humidity is varying from 50 to 60%. This is the comfortable relative humidity for the human occupancy. And the velocity is, velocity you should maintain in between 3 to 7 meters per minute, not per second. These are the year-round comfortable conditions. Anyhow, since it is given for comfortable relative humidity, I can take 55 to 60. Option C can be selected. Okay, na? Similarly, look at the other one. White ice is subcooled water? No. Rapid cooled water? Also no. Ice containing dissolved air, gas and impurities? Absolutely correct. If the air is if the ice is if some dissolved gas are there with the ice, that ice is called white ice. So white ice is containing dissolved air and gases and impurities. Therefore, option C is absolutely correct. Okay. Similarly, look at the other one. Azeotrope. Azeotrope is the mixture of 2 or more halocarbons. The azeotropes are kept in 500 series. The azeotrope R501 is a mixture of, dear friends, remember, the azeotrope R501 is a mixture of R12 and R22. R501 is the mixture of R12 and R22. The R22 quantity is 75%, right? Whereas R12 quantity 25%. So that is the percentage of the R12 and R22 for the azeotrope 501 or 501. Therefore, option B can be selected. Okay. Similarly, look at the other one, very simple questions. The compressor used in a domestic refrigerator. The compressor used for domestic refrigerator is called hermetically sealed compressor. Dear friends, remember that hermetically sealed compressor is a reciprocating type only. Hermetically sealed compressor means that reciprocating compressor is placed in the weld shield. So option A is absolutely correct. Okay, very simple questions. Similarly, look at the other one. In vapor compression cycle, subcooling of refrigerant before throttling. Dear friends, remember, because of the subcooling, refrigeration effect increases. Then, right, COP equal to what? COP equal to refrigeration effect by work input. Now, because of the increase in refrigeration effect, COP is going to increase. Now, the COP equal to what? COP equal to refrigeration effect by work input to the compressor equal to refrigeration effect divided by COP. If you want to decide the work input with subcooling mechanism for the same cooling effect or for the same refrigeration effect, for the constant refrigeration effect, because of the subcooling, since COP increases, work input decreases. For the same refrigeration effect, because of the increase in COP, work input decreases. So therefore, reduces power consumption can be selected. Increases power consumption, no. Increases evaporator, no. Reduces superheat, no. Reduces power. For the same refrigeration effect, definitely the power consumption decreases. Okay. So option D can be selected. Similarly, during sensible cooling process. The sensible cooling process means what? The process of decreasing the method of decreasing the dry bulb temperature of the atmospheric air at constant specific humidity is called sensible cooling process. That sensible cooling process in the psychrometric chart. Look at the psychrometric, right, chart. This is how the psychrometric chart is appearing. Dry bulb temperature, specific humidity. This is the saturation curve. Along this saturation curve, RH value, that is the relative humidity, equal to 100%. The method of decreasing the dry bulb temperature of the atmospheric air at constant specific humidity is called sensible cooling process. This is the representation of sensible cooling process. So sensible cooling is happening at constant specific humidity. As long as the specific humidity remains constant, dew point temperature remains constant. You know, this dew point temperature is the saturation temperature corresponding to partial pressure of water vapor. Since dPT remains constant, partial pressure of the water vapor remains constant during the subcooling process, sensible cooling process. In both sensible cooling process and sensible heating process, specific humidity constant, dPT constant. When the dPT is constant, the partial pressure of water vapor remains constant because dPT is the saturation temperature corresponding to partial pressure of water vapor. Therefore, look at the options. Relative humidity value remains constant? No. W, wet bulb temperature increases? No. Specific humidity increases? No. Specific humidity remains constant. Partial pressure of vapor remains constant. Option D is absolutely correct. Dear friends, remember, during the sensible cooling process, look at the right sensible cooling process. So this is the relative humidity curve at state 1, RH1, and this is the relative humidity curve at state 2, RH2. The right state 2 is very close to saturation curve. This RH2 more than RH1. That means during the sensible cooling process, the relative humidity increases, but it is given constant. Wet bulb temperature. Look at the wet bulb temperature. So this is the wet bulb temperature at state 1. This is the wet bulb temperature at state 2. The wet bulb temperature at state 2, TW2, is less than TW201 because wet bulb temperature value increasing from bottom left to top right. So during the sensible cooling process, wet bulb temperature decreases, but what it is given, wet bulb temperature increases. That's why it is not correct. Specific humidity increases. No, specific humidity remains constant during the sensible cooling process and sensible heating process. Therefore, first three are absolutely wrong. partial pressure of water vapor remains constant because of the constant dew point temperature. Understood clearly? Very simple questions. With this, the solutions for the R and AC, refrigeration and air conditioning questions completed. Okay? Yes. Dear students, now let us take the questions from IC engines part. Okay? Look at the very first question from the IC engines, asking like this. Morse test can be used on option A, low horsepower engines only? No. Variable speed engines only? Also no. Multi-cylinder engine only? Absolutely correct. Water cooled engines only? Absolutely wrong. Dear friends, remember, Morse test is used for finding the indicated power and frictional power for multi-cylinder engine. Therefore, option C is absolutely correct. Okay, na? Very simple question. Similarly, look at the other one. The total sulfur content in petrol is limited to. Dear friends, remember, under any circumstances, the sulfur content in the petrol should not be exceeding, right, 0.05 percentage. Therefore, option A is absolutely correct. You have to remember that value, right? Under any circumstances, the sulfur content in the petrol should not be exceeding 0.05%. Option A is correct. Similarly, look at the other one. In RSAT apparatus, oxygen is absorbed in, in RSAT apparatus, oxygen is absorbed by pyrogallic acid. Option C is absolutely correct. Simple question, very simple question. Similarly, look at the other one. Mixer formation in a carburetor is based on the principle of, right, Venturi principle, right? The mixer formation, the petrol particles are mixing with the air in the Venturi part of the carburetor. That's why that is called Venturi principle. Option B is absolutely correct. Okay, simple question. Similarly, in a diesel engine, the pipe carrying fuel from fuel pump to nozzle is generally made by steel. The pipe for carrying the diesel particles from the pump to engine cylinder, right, or nozzle is made by steel. Therefore, you can take the option C. Similarly, very simple questions. Not many changes will be needed in case of normal diesel engine. In villages, in olden days, right, my father was using kerosene for the diesel engine for lifting the water to the agriculture purpose from the big well. That means even if I use the kerosene for the diesel engine, it can be properly working without any much troubles. That means not many changes will be needed in case of normal diesel engine, even if I use the kerosene as the fuel. But you should not use the kerosene for the petrol engine. Anyhow, kerosene can be used for diesel engines also, right? Even if I use the kerosene for diesel engine, it does not give any trouble. Okay. Similarly, look at the other one. For the determination of cetane number, test is conducted on mixture of cetane with alpha methyl naphthalene, right? So for the determination of cetane number, test is conducted on a mixture of cetane with alpha methyl naphthalene. Therefore, option B is correct. The octane number for the petrol is decided by normal heptane and isooctane. Similarly, right, so with the cetane and alpha methyl naphthalene, the cetane number will be decided. Similarly, look at the other one. Reference fuels for knock rating of SI engine fuels would be including isooctane and alpha methyl naphthalene? No. Normal octane and hexylene? No. Isooctane and N-hexane? Not correct. N-heptane and isooctane? Option D is correct. The knock rating of the petrol fuel is decided in terms of N-heptane and isooctane. Therefore, option D is absolutely correct. Okay. Similarly, look at the other one. The objective of providing masked inlet valve in the air passage of the compression ignition engine is. Compression ignition engine means diesel engine, right? The masked inlet valve is for producing the primary swirl or induced primary swirl. Option C is absolutely correct. The masked inlet valve is for producing the primary swell or induced primary swell, right? So that part already you might have studied. Similarly, look at the other one. Generally, in Bosch type fuel injection pumps, the quantity of the fuel is increased to decrease with change in load due to change in timings of start of fuel injection. Option A is absolutely correct. Generally, in a Bosch type fuel injection pumps, the quantity of the fuel is increased to decrease with change in load. When the change in load is happening for increasing the fuel supply due to change in timing of start of fuel injection is absolutely correct. Similarly, look at the other one. Which one of the following quantities is assumed to be constant for an internal combustion engine while estimating its frictional power by extrapolation through Whelan's line, right? Generally, we are assuming the indicated thermal efficiency remains constant while we are marking the Whelan's line, right? Whelan's line for finding the frictional power. So, indicated thermal efficiency is treated as constant while we are marking the Whelan's line for finding the frictional power. Option B is absolutely correct. Similarly, look at the other one. Knocking tendency in SI engine reduces with increase in option A, compression ratio. No, if compression ratio increases, knocking tendency increases, but it is asking how to decrease the knocking tendency. It is not correct. Wall temperature, no, by increasing the wall temperature, knocking tendency increases, right? This is not correct. Supercharging, you should not go for supercharging for the petrol engine. Supercharging is recommended for only diesel engine. If I use the supercharging mechanism or turbocharging mechanism for petrol engine, the knocking tendency increases. But when you increase the engine speed, knocking tendency of the spark ignition engine can be reducing. Option D is absolutely correct. Okay, look at the last question. It is asking like this. An IC engine has a bore and stroke of 2 units each. That means internal diameter of the cylinder equal to stroke length equal to 2 units. The area to calculate heat loss can be taken as, you are asked to decide what is the heat transfer area. For that, look at the cylinder with piston mechanism. Because of the fuel burning inside the engine cylinder, large amount of combustion products are developed. Those combustion products are driving down the piston. But the heat is transferred to not only cylinder walls but also cylinder cover and piston. Therefore, the heat transfer area, total heat transfer area equal to circumferential length of the cylinder, that is pi dl, plus the cylinder cover area, that is pi by 4 into d square, plus the piston surface area pi by 4 into d square. It is equal to pi dl plus, since these two quantities are equal, it is 2 by 4 into pi into d square. It is equal to pi dl plus pi by 2 into d square. It is equal to pi into d equal to 2, l also equal to 2, l also equal to 2, l also equal to 2, plus pi into 2 square is 4, d square means 2 square, 4 divided by 2. It is equal to 4 pi plus 2 pi, it is equal to 6 pi. That is the heat transfer area. Option C is absolutely correct. Understood clearly? Yes. With this, the solutions for IC engines part also completed. Thank you. Thank you very much.